Hello! Visual Studio 2017 release brings built-in support for developing C++ projects with CMake. My name is Marian Luparu, and in this video, I'll introduce to you the new Visual C++ tools for CMake and how they work. CMake already has support for generating VS projects, so you can develop your CMake projects with any version of Visual Studio. But with 2017, VS has fundamentally changed the way we will interact with CMake projects. Now you can open folders containing CMake projects directly in the IDE. There is no need to run the CMake generation step on the command line first. And once you are inside the IDE, you won't have to switch back and forth to the command line anymore. We've also took this opportunity to adapt the VS UI to focus around your sources, the CMake files, and their capabilities, rather than generated MS-built counterparts. Specifically, you will be able to explore your source code in a folder-based view and have access to CMake-specific configuration knobs. And as you make changes to your CMake projects, VS will take care of keeping the IDE environment in sync with your CMake projects and provide you with the best C++ code editing, building, and debugging. To take advantage of the CMake integration, make sure you install the C++ desktop development workload and select the Tools for CMake optional component. Now, all you need to do to get started with VS is to open a folder containing a CMakelist.txt file through one of the supported methods, either from the File Open menu, Start page, or directly from the command line. So, let's see this in action. In this demo, I'll open a folder with a very simple CMake project. It only has one target that compiles a very simple C++ file with a hello world message. So let me give you a tour of the IDE. The first thing you'll notice when you open a folder with a CMakelist project in it is that the output window will automatically switch to CMake mode and will run a CMake command. This CMake command configures the folder that you just opened, and it uses the information from a default CMake configuration created by Visual Studio. The list of CMake configurations are available in this dropdown, and you can switch at any time. By default, there are only 2 available, but you can customize the settings in each of them or create as many configurations as you want. Solution Explorer, as I mentioned earlier, it's displayed in folder-based view rather than a project-based view. And if you right-click on the CMakelist.txt, you will observe CMake-specific commands like build, install, clean, or debug. Speaking of debug, if you look at the debug target dropdown, you'll notice all the debug targets that are coming from the CMake compilation. So hello here would be an executable target. What I'll do next is add a new target to CMake. So I already have this CMake list open here in the test folder that creates an executable target called hello test, and it adds the same hello CPP file that it's in the root, but under a specific define called text code. So to do that, I'll go into the root CMake list and add subdirectory test. As soon as I save, you'll notice the output window refreshes and it reconfigures CMake environment. This reconfigures the whole IDE environment to read the information from the CMake project. And now, IntelliSense is fully up to date. So remember, I included the hello CPP text in both the targets. I can switch between them and I can get seamless IntelliSense experience. So you can see the text code being defined in the hello test target. Now it's getting enabled. Also, in the debug target, the new target has appeared. Let's do a quick debug session. Let's set a breakpoint over here, and let's click Run. As you would have expected, the hello test project is being debugged, and you can see 2 messages being displayed, one from the hello and one test. What I want to do next is show you how to configure the debugger. So let's say you want to pass additional switches to your process. To do that, you will right-click on a CMakelist.txt and say Debug and Launch Settings. This creates a new file called launch.json in which you can create as many debug configurations as you need. This is for the CMake list, this entry is for the CMake list.txt file. And let's customize the name because we want to debug the tests hello test. And we want to pass some arguments. And to be specific that we want to debug the test hello test target, we will have to call it out in this file. Otherwise, this being an optional parameter, we will just pick the first executable target, which would be hello. So let's just say here tests hello test. And now let's pass the additional arguments we wanted to pass. After I click Save, the new entry becomes available, and all I have to do is select it and click Run. You can see that the argument count now is 4, so this worked, and now all the arguments get displayed. All right, that's the first demo. Now, let's switch to a more complex real-world project. For this demo, I've selected the FreeRTC, which is a roller coaster simulator written in C++, and it's using CMake as a build system. When I load it inside Visual Studio, CMake already starts and configures the project, and as you can see in this case, I am using the 2015 generator instead of 2017. I also had to pass additional configuration settings to CMake to successfully make it configured because of the dependencies the project has. To do that, I created 2 new configurations that replaces the default one that Visual Studio generates. And that is achieved by creating a new file called CMake settings.json that sits in the same folder with the CMake list.txt. Let me open it really quickly and show you what I have in it. In here, you can create as many configurations as you want. And I only created an x86 debug and an x64 debug. As I mentioned earlier, I have selected the generator, and here's the full list of generators that are currently supported. We are working of adding more generators to the list. There are additional settings you can configure, like the build route, additional CMake commands that you want to pass as arguments, as well as variables, which really map to -d argument for CMake, but for readability, we have expanded it to a specific property, as well as build command arguments, which in this case would get passed to the generator, to MS-build. It's important for a CMake generation to complete successfully because that's the moment when Visual Studio has access to the full information of how you're building your CMake projects. And this is how it can provide a seamless editing, building, navigation, and debugging experience inside VS. So for example, because the configuration completed successfully, I have full access to the list of targets, and I can start immediately debugging. So I already have built it before. Let's see it in action. I can already step over in debugger. Hitting F5 will show the game. Still a work in progress. Amusement park. And I can also use all the navigation and code editing experience that you're familiar with in Visual Studio. So let's say I want to search for a symbol. I actually want to search for a type. Image file, let's say. It'll open the file in the editor, and you can see semantic colorization working. I can right-click and find all the references for a given symbol. I choose to group by read and writes, but you can customize your grouping as much as you want. Also, refactoring works, so I can click on this member, and let's say if I want to use Hungarian notation, I will go with this name. I can preview all the changes. And at the end, I can click Apply, and all the changes will be applied. This is the kind of experience that you're familiar with MS-Build, and the same experience now is available for your CMake projects as well. All right, that's our demo for now. To learn more about the CMake support in Visual Studio, follow the link to our blog. We look forward to you trying Visual Studio 2017 and sharing your feedback, either in the comments below or on our blog. Thank you for watching, and have a good day.